In this problem, we want to determine the magnitude of the resultant force, knowing that Fb, the force from A to B, is 700 newtons, and Fc has a magnitude of 560 newtons. So to start this, I'm going to write Fb and Fc in the Cartesian form. And in order to do that, I need to take those magnitudes, 700 and 560, times the unit vector in the direction from A to B and A to C. And that unit vector is found by taking the position vector going from A to B divided by the magnitude of that position vector, which is essentially the length from A to B. Okay, so moving from A to B, okay, I end at 2, start at 0, so I move 2 in the x direction. I move minus 3 in the y direction. And I move negative 6 in the z direction to go from A to B. Okay, so again, 2 minus 3 minus 6. Okay. The magnitude of that is basically 2 squared plus 3 squared plus 6 squared, which actually gives me 7. So my unit vector to go from A to B is 2/7 I minus 3/7 j minus 6/7 k. So 2 over 7, 3 over 7, 6 over 7. Okay, so the force vector, Fb, I just take that unit vector, which just gives me my direction, and I multiply it by 700 newtons. So 700 times that unit vector I found above gives me this force equation right here for B. So I'll do the same thing for C there. Okay, so moving in the x direction, I move 3, going from 0 to 3. In the y direction, I move 2. In the positive direction from 0 to 2. And then in the k direction, I again move negative 6. So I get 3 plus 2 minus 6 for my x, y, z components. The magnitude of this one is again square root of the sum of the squared. So it's going to be 3 squared plus 2 squared plus 6 squared, which again is 7. So I get 3/7 plus 2/7 j minus 6/7 k. That's the unit vector going from A to C. That gives me the direction of that force. Again, I get that from the position vector divided by the magnitude of that position vector, or the length of that cable. So Fc is then 560 times that unit vector, and those numbers are given right here. So this is Fb written in Cartesian form. That's that 700 newtons put into its x, y, and z components. And this is the 560 newtons put in its x, y, and z components. Okay, so now that I've got those forces, I do just like I've done before in finding resultants. Add up my x's, add up my y's, and add up my z's. Okay, so here's Fb. I add it to Fc, so I plus I is 440. J plus j gives me negative 140. And then k plus k gives me a negative 1080. Then to find my magnitude, I just take the square root of the sum of the squares. Okay, so 440 squared plus 140 squared plus 1080 squared, and I get 1175 newtons, or 1.17 kilonewtons. So again, you just write each force in Cartesian form, sum up your x's, y's, and z's to get your resultant force. Okay, in order to write those in Cartesian form, you just take the magnitude of the force times the unit vector, which is the position vector of the cable going in the direction of the force. That position vector divided by its magnitude, which is the length of the cable. That gives you your unit vector. Multiply that times the magnitude of the force to give you the force vector written in Cartesian form.